Hello everyone. In the previous class, we discussed about the openings in laminated rock where the roof may be inclined. So, let us continue the discussion from the previous lecture. Today, we will see that those three cases, how we can define those and how we can determine the maximum possible support system, or how we can find the optimum support system for each of those cases. So, as I mentioned that we had three cases and we were discussing about this case 1, and this particular aspect of case 1 we already discussed. So, just for the continuation, let me repeat it once again, that in case if the beds are not parallel to the roof or they are inclined as shown in this figure, and in the case 1 where the laminations are inclined in a way as shown in this figure, and if this alpha is equal to 0 degree, this means that we are going to have the horizontal plane of weakness, and therefore the horizontal excavations are going to be designed either by beam or plate theory based upon the aspect ratio of the opening. Second thing was that the stress concentration and compressive strength of the rock in the side walls, they can be treated as if the rock were isotropic. So, this we discussed in the previous class, and I mentioned to you that there can be various ranges of alpha that we will be considering, and based upon that we will be deciding that what will be the optimum support system. So, we take the another case where this alpha varies between 0 degree to 20 degrees. This signifies the low or mild angle of dip. What happens to side wall? There comes a problem, that is that the side walls remains virtually the same as for alpha equal to 0 degree, because in this case now rock will fail across rather than on the lamination planes. So, basically in this case the critical roof problem is going to be when the roof forms along the dip. So, take a look here, how are we going to visualize this. So, let us say that let me draw the figure here. So, this is what is the opening, and then we have the inclined roof. Now, this angle is alpha, and this is what is your inclined roof. So, what will happen? There is going to be the development of these shear. So, if the roof forms along the dip, it can be considered on the basis of an inclined roof, as has been mentioned in this particular figure. Now, if the top of the opening is kept horizontal, what will happen to the layers? These lamina will feather into the roof at a low angle, because alpha is in between 0 and 20 degree, and there is going to be the creation of unsupported thin wedges of rock which will be weak, and it will be very difficult to detect these. Let us take a look that how this will look like. So, in this case you see that you have the roof of the excavation as the horizontal one, but then you have the inclined lamina planes. Now there is going to be the development of shear here, and see, wherever they intersect the roof or the side wall, there is going to be the formation of wedge. Here, then in this region, which will try to move like this. In this region, here also, then here, here. And these are going to be very difficult to detect. So therefore, this creates the problem. Now this happens, here this angle is alpha. So what happens is, we need to be careful for deciding the inclination of the roof of the opening, because if we keep it horizontal, this is what is going to be the problem. Now there can be additional problem of sliding of slabs in roof also. Failure of rock slabs will occur in side walls because of two reasons. One is due to the transverse shear, and the other one is that the value of the maximum normal stress exceeds the tensile strength. Now in this case, the general stability or the overall stability of the excavation will not be seriously affected due to low or mild dip of lamination. So here is the catch. So what all are the remedial measure in case if alpha varies between 0 and 20 degree? So what we need to do is, one needs to provide the rock bolts to stitch the rock slabs, and both in the roof and the side walls of the excavation, systematic rock bolting can be provided. Wherever you observe the failure zones, one can go for the spot rock bolting. In the case when alpha becomes even larger than 70 degree, that means it varies between 70 degree and 90 degree, we can say that these laminations, they are almost vertical. So in that case, the stability of the opening will depend upon the type of the stress field to much larger extent. So what all are going to be those state of stresses? So we can have the two situation here, that is when the alpha is varying between 45 degree to 70 degree, and the another situation is going to be when it is varying between 70 to 90 degrees. In both the cases, the in situ stress field will be deciding the overall stability. Now if you recall, we defined these in situ stress field situation with a factor called M, which we named as mobilization factor. This we discussed in some of our earlier classes, and this was defined as SH upon SV. That means the in situ stress in the vertical, that means the in situ stress in the horizontal direction by the in situ stress in the vertical direction, SH upon SV. And based upon this, we defined three types of the stress field. One was the uniaxial state of stress, where we define M to be equal to 0. The second one was the biaxial state of stress, where we had M varying between 0 and 1, and if you recall, typically we took M to be equal to 1 by 3 when we were discussing about the non-circular openings and the stress distribution. Then the third was the hydrostatic state of stress, there this M was equal to 1. So, we have different situation, m to be equal to 0, then m varying between 0 and 1 and m equal to 1. So, let us come to first the hydrostatic state of stress, because in this case the excavation will be by and large stable. The reason being that the state of stress that will be developed all around the periphery of the opening is going to be all compressive in nature. So, more or less in this case the excavation will be by and large stable. Coming to the uniaxial state of stress, there is going to be the development of tensile stresses in the crown portion of the opening. This we have seen earlier as well, and this will significantly affect the stability of roof. So, in this case the stability of the roof is adversely affected. So, what will happen in this case? The bond strength in tension across the planes of weakness will govern the design. So, these are the two extreme situations, that is uniaxial state of stress and hydrostatic state of stress. Come to the biaxial state of stress. So, somewhere you will have in between situation. Now, here again focus on the uniaxial state of stress, that is when m equal to 0. So, when we have m equal to 0, when these plane of weakness and the bond strength across these, when they govern the design, so then these may necessitate the provision of steel sets. Now, in case of the side walls, there is always the uniaxial situation. And this is hydrostatic away from the boundary. So, therefore, we need to understand all the conditions, that is uniaxial, biaxial and the hydrostatic state of stress. Remember, always remember that uniaxial state of stress is the most critical one. So, this was all about case 1, and then we had the second case where this was defined as that the plane of weakness is an inclined plane, as has been shown in this figure. Then the dip was defined as beta degree with respect to longitudinal axis of the cavity, which is the x axis here, and the strike was perpendicular to the longitudinal axis, as it is clear with this figure. So, in this case also, based upon the value of beta, we have various situation. So, in case if this beta becomes equal to 0, so you just take a look at this figure, that if this beta becomes equal to 0, again there are going to be the horizontal laminations with strike perpendicular to the longitudinal axis, and therefore, this case becomes analogous to case 1's first part where alpha was equal to 0, and therefore, we can go for the remedial measures as we discussed for case 1 part 1. But then if beta is varying between 0 and 20 degree. So, in this case what will happen, that the side walls will have the same situation as for the case 1 part 2 when alpha was varying between 0 degree and 20 degree. What will happen to roof? In case of the roof, the situation is going to be different as compared to this particular case, because in this case the lamina will feather into the roof at a low angle, but the lamina edges will strike normal to the long axis of the opening, and therefore, roof cannot be formed along a plane of weakness. In the previous case we could do that, but in this case it may not be possible. So, in this case one has to go for the systematic rock bolting. As far as roof is concerned, this results into the stitching of layers and or the weakness plane. So, let us take a look at how this situation will look like. So, if you take the longitudinal section of an excavation, it will look like this. That is the center line, and here is the roof portion, and this will be the floor portion. So, I will just mark this as maybe roof, and here it is the floor, and the plane of laminations, they will feather like this, feather into like this. This angle is angle beta, and there is going to be the movement like this in the roof portion. So, therefore, in the roof portion one has to go for systematic rock bolting. So, this is what, so here all these planes are there in the roof portion. So, what we have here is the longitudinal section of excavation. In case if this beta varies between 20 degree to 70 degree, so what happens is as this beta gradually increases, dip becomes steeper. The rock slabs are comfortably seated over the infinite width of the roof, and this results into more and more stable excavation. So, no problem for us. In case of the third situation where we have the situation as shown here, that is when the lamination planes, they are nearly vertical. So, in that case again we have different situation, that is when gamma is equal to 0 degree. This is analogous to case 1 when alpha becomes equal to 90 degree, and in this case steel sets are provided as the support system. But if gamma becomes equal to 90 degree, see what is this angle gamma as shown here in this figure, this angle is angle gamma. When this is 90 degree, this becomes analogous to case when we have beta as 90 degree, and therefore, this is going to be the stable and most favorable condition as far as the openings are concerned. If the angle gamma varies between 0 degree and 20 degree, This case is analogous to the situation when you had the case 1 where alpha was varying between 70 degree and 90 degree. In this case, the rock slabs may slide into the cavity for the uniaxial state of stress, that is when m is equal to 0, and accordingly there you have to provide appropriate and the corresponding support system. In case if you have gamma angle varying between 70 degree and 90 degree, this is analogous to the case when beta is varying between 70 to 90 degree, and then you can refer back to the case 2 and provide the appropriate support system as we already discussed. In case when gamma is varying between 20 degree and 70 degree, what will happen in that case? This is analogous to gamma equal to 0 degree. So, in this case some light roof and wall support may be needed. So, basically from all these 3 cases, based upon the orientation of the planes of lamination with reference to the orientation of the opening, you can decide that which case it is. In case if the laminar planes they are horizontal, we can use the beam or the plate theory depending upon the aspect ratio of the opening. But in case if that is not the situation in different cases, then appropriately you can refer to these different situation and pick the appropriate support system. Thank you very much, and in the next class we are going to discuss about the new topic, which is the elastoplastic analysis of the tunnels. If you have noticed, as of now we discussed everything considering the rock as the elastic medium, but that may not be the case. Upon the excavation, what happens is the surrounding rock become loosened and it may enter into the plastic state. So, how should we go for the analysis of the opening in elastoplastic rocks, that we will learn in the next class.